Okay, so the solutions of the test here, guys. So let's look at the first question. This was worth 15 marks, 5 each. State the domain and the range for the relations presented by each of the following graphs. And then you are to state whether each of the graphs represents a function, giving a reason for your answer. Okay, so we're going to start off with the domain and range. So for part A, my domain would be, okay, so when you are asked for the domain, it's basically how far left can I go? How far right can I go? In this case, there's no limit. No matter how far left, no matter how far right, there will always be the graph present because we're assuming that graph continues on. So for that reason, it goes from to negative infinity up to positive infinity and rounded brackets, parentheses on each side because it technically isn't a start and an end because you can't actually reach infinity. Now, regarding the range is how high and how low can I go? We always start with the low. So this graph only goes as low as -2, and there's no part of the graph below that. So the very lowest I can go is -2, including -2, which is why I have a square bracket. But then there's no limit to how high I can go because those legs of the graph can keep going. So it goes then to infinity and a rounded bracket there. I'll come back to the function in a sec, but I'm going to do part B next. So for the domain, how far left can I go? How far right can I go? There doesn't appear to be a limit regarding how far left because these legs we assume continue. So negative infinity. Regarding how far right can I go? Well, the graph ends here at 2. So I can't go past 2. So 2 is the furthest right I can go with a square bracket. Regarding the range, how low can I go and how high can I go? Now, there's no limit here either because if I was to allow that axis to keep going down, the leg keeps going. So there's still going to be y values, same on top. So there's no limit. Now, some students wrote their real numbers, and that's fine as well, because real numbers is the exact same as saying from negative infinity to positive infinity. Sorry, this is a little bit faint here, but regarding C, so if we start with the domain, how far left can I go? How far right can I go? So here we have our circle. So I understood there was no numbers here, guys, but and same there actually. But this is a circle, so our radius is going to be in the dead center. So if the radius is at -2, then we would assume that this is -4 and this is +4. So regarding the domain, we can't go further than -4. So -4 is the lowest in terms, sorry, I should say is the most left I can go. And the furthest right I can go is to 0. They're both square brackets because the furthest I'm going left and right has a start and an end. It doesn't go on forever. Regarding the range, how low can I go and how high can I go? Well, the lowest I can go is 0. The highest I can go is 4. So I go 0, 4, and in that order. Now I want to say whether they're functions or not, giving a reason for my answer. So for a function, I'm going to do a vertical line test. If I do a vertical line in the first one, I can see it meets the graph once. So if I do if I do a vertical line test, some of you said horizontal. Horizontal is the test we do if we're trying to decide whether it's surjective, injective, or bijective. But it's a vertical line if you're trying to decide if it's a function. So vertical line test shows it's a function. Now, the reason that part A is a function is because the vertical line test shows it touches the graph once. So shows it's a function. The line touches the graph once. So not more than once, basically. In the next one, if I do my vertical line test anywhere, I can see, so same words here again, vertical line test shows it's not a function. Why? Because the line touches the graph more than once. the line touches the graph more than once. So for that reason, it's not a function. The last guy, if I do my vertical line test somewhere, again, exact same reason as I've just written there. So repeat that over here. It's not a function because the vertical line test shows that it meets the graph more than once. That was 15 marks, 5 marks here, 5 marks here, 5 marks here. What is the y-intercept? Now, this question, these were one of the ones where I said some of you made a lot of work out of it. I don't know if you remember when we were doing completing the square and we talked about how we can immediately read off the intercept. We said it was whatever number was in the second position squared. So straight away, we knew that it was 0.64. If for any reason you didn't know that and you were missing that lesson, surely we know if it's the y-intercept, x is 0. Now, we should know that since junior cycle. So if I put 0 in here, I simply get minus 8 squared is 64. So my final answer is 64. Whether I do it using the turning point method we learned in class, or whether I do it using the very, very simple intercept. Some of you wrote down just 64 straight away, which is totally acceptable. I only gave 1 mark for this, and the reason is because, you know, I thought, oh, it's just a quick 2-second job. Some of you spent way too long on that question. Okay, the next one. Again, this was another really straightforward. Some of you went off and you started graphing these on the calculator. There was absolutely no need to do that. So what have we learned here? So for this one, we had the original graph as x squared plus 2x plus 3. So we had that original graph here at the bottom. So that was the first one. Now, how do I know any of these? Sorry, my pen is out of action for some reason. How do I know what's what? So very simply, I can do the same type of concept. If you think about it, if you think about the y-intercept, before you do anything else or know anything else, if I have the original graph and I want to think about the y-intercept, I let x equals to 0. If I do that, very quickly, I see that the y-intercept is going to be 3. So I immediately know that that's that one. If I do the exact same thing for the others, so let's see this one here. If I let y equals to 0, I will very quickly find out where it crosses the y-axis without any effort. It crosses there. So I immediately know that's g of x. And then the other one by default has to be h of x. That was another 2-minute, like not even 2 minute, 1 minute thing to do. I gave 2 marks for that, again, because it was like a 2-second job. Now, we know a little bit more about it now. Like, for example, just from what we did in today's lesson, like if you compare him to him, you'll see that the only difference is that the number seems to have gone up 1. So basically, f of x is being translated up 1 to make h. If you look at your graph, is that true? Absolutely. I mean, if you start at 3 and you jump up 1, you land at 4. And that's exactly what h of x is. So you can look at it in that light as well. Okay. So what else could we, actually another thing we did today, now you didn't have to do any of this, but just to, I suppose it's nice to connect it. To see the yellow one, if I compare the yellow one to the original, do you notice that if I factorized out the 2, the graph is, so really what I'm doing here is I'm doubling all the x values really. So what's going to happen? Well, I'm not actually doubling the x's, sorry. I end up doubling the y values because whatever I fill in for x is going to now get doubled. So that's exactly an example we did in school today where we looked at what this means, what that number means. So what that number means is all the y's get doubled, basically. And does that make sense? Well, it does, because again, if I bring you back to here, in the original graph, one of the y values was 3, and this y value is 6. So that's doubled. If we could read any of the other y values, I mean, this y value may be here. I reckon that looks like a 2. And then look at the corresponding y value is 4. So can you see that what's happened here is it has been stretched, basically? Okay. So It's so you can see it's thinner actually. It kind of looks like, I mean, obviously it's in a different place, but really it's a stretch because you're doubling all the Y's, whatever the Y's were, they're now doubled. So anyway, that's that one. I might stop the video there actually and do another one because it won't load up otherwise.